Hello and welcome. This is a Edexcel for the Pure 1 AS or whatever you do video. This is on. We've finished complex numbers now. We're looking at finding roots or solutions to equations where we're told given interval and we have to find. There's various methods we could use. So generally, what the kind of thing I'm talking about, sorry, pens over here, is finding something like this. So it's x cubed plus 2x take 2 equals 0, for example. Now, normally if you had something like this, you go, well, we'll factorise it. Well, you can't really factorise that off the top of your head. It's going to be really difficult. I don't think it factorises at all. Okay, so really that's the kind of thing that we're working with. And obviously there's other variations, such as the latter one we're going to look at, where it's 2 to the power of x take 3 equals 0, and we've got to find the roots of equations such as these. Now there are many different ways that we can find the roots of these equations. There's a couple of methods that we'll be going through, so it's a fairly short kind of topic in terms of complex numbers. Was really long and it took a while to go through, whereas this method of solving equations, where what we call that f equals f of x equals 0, solving equations like that, we've got a function of x that equals 0. There's about three ways that we can do this, and the first one we're going to look at today is called the interval bisection method. Now, it sounds very, very fancy, and it's actually a hell of a lot simpler than it sounds. Okay, so let's go back to that first one we just had on the board there. I don't know why I really rubbed it out. So x cubed take 2x, x cubed plus 2x take 2 equals 0. Okay, so generally, when you're using this method, well, generally you will, you'll be told two extremes. So, you're told the interval lies between, in this case, 0 and 1, okay? And you will be told, what degree of accuracy do you want? Now, we're not obviously talking about degrees. We're obviously talking about, decimal places or whatever it may be, because we did something similar to this in, well, it depends where you are, as I said. So you do something similar to this in the latter part of C3, where you look at change of sign through an irritation kind of. It's the irritation topic and it's a change of sign. It's kind of the same thing as this, where you put an x value in. Say this, I don't know what the curve looks like, obviously, but obviously we know it goes through 0 and 1, so I'm just going to write 1 on there, and it'll do something like that. And if you put an x value that was less than 0 in, you would get a negative number for y, because obviously when you put x to be something in there, you get, because y equals x cubed plus 2x take 2, and we put equals 0 because obviously that's where it is, where it crosses the y-axis, x-axis even, God. Okay, so now, as I said, I don't know what that graph looks like, but we know it looks something like that. So you get the idea of, if you put an x value in that is less than the root, which you're going to get negative, and if it's greater, you get a positive. So what the hell is this interval bisection? Okay, well, a good way of remembering it is obviously remembering the name. But bisection, when you hear the word section, you think of splitting something up. And that's kind of what we're going to do. Now, we know it's between 0 and 1. But as I said, we don't have, we don't know what a specific number is. That's obviously what we're being asked to find out, obviously. And the key thing with this is there's no formula. So there's no formula in the back of your exam that'll say, this is the interval bisection method. So it's more logic and remembering steps than an actual method. Than an actual, equation. And so it's a method, really. Basically, what we do is we keep halving the range until we get to such a small value such a high, the degree of accuracy we want. I mean, we could carry on going forever and ever and ever, assuming the intercept is not 0.5. We don't know that. I'm just saying it's probably not going to be that. And you would keep going until whatever it asks you to. So we'll go through this 2 examples just so you get the gist of what I'm talking about. But really, it's just keep halving the range and going through. Okay, so if we halve the range, we halve between 0 and 1. Obviously, so the first thing we would do is put what f of 0 is. And if you put f of 0 into this equation, so it would be 0 cubed plus 2 times 0 would take 2. Obviously gets you negative 2. And if you put f of 1 in, now they should have a change of sign, or the exam's lying to us, which generally doesn't happen. You put f of 1 in, so it's 1 cubed, which is 1, plus 2 times 1, which is 2, so it's obviously 3. 3 take 2 is 1, so therefore the f of 1 is positive 1, hence there's been a change of sign. Okay, now, therefore we know f of 0, the y-intercept is negative 2, and at 1 we've got a y-coordinate of 1, okay? So at x equals 1, y equals 1. So we're kind of focusing in, so we're trying to narrow it down. So halfway between them 2 ranges is 0.5, obviously. 0.5, if you were to sub 0.5 into that, you would get negative 0.875. Okay, now that's negative. So, okay, so where do we go from here? What do we halve? Do we halve between 0 and 0.5 or 0.5 and 1? Well, you have to look where the change of sign occurred. Now, if we were to continue in halving the range between 0 and 0.5, obviously then we'd do f of 0.25 and f of 0.125, or whatever method we would continue to use, we'd continue getting negative numbers because there's not been a change of sign between 0 and positive 0.5. So therefore, we draw 0.5 somewhere on over here. We know all the way past, all the way on the left hand side of 0.5, we get a negative value for y. Okay, so we're not going to consider the 0.5 below 0.5, okay, because all of that is going to be 0. What we're going to the change of sign has been between 0.5 and 1, okay? So it might be helpful, if you, I don't know how you work, your mind works, but it might be helpful to draw a number line. I know that sounds incredibly simple, but it's just to know which way you're looking at. Okay, so I'm just going to draw 0.5. This is why it's very simple. Okay, so anything on the left hand side of 0.5, I'm just going to ignore. Okay, so it's a squiggly line. Now we're focusing on this range because between this is f of whatever. Okay, so f of x, f of 0, f of 0.5, f of 1. Now we know the changes between 1 and 0.5, so we're going to be focusing on this range. So we keep halving this range and halving it and halving it and halving it until we get to whatever degree of accuracy that we want. Now, in this particular question, it asks for 1 decimal place. Now, obviously, that's, you could round that up to 0.9, but it's just it's the first positive figure really that we're looking for, or the first change of sign, because it starts at negative and we want it when it changes to positive. Okay, so it's the first sort of smallest positive value that we can get, and it's whatever the x would be at that point. Okay, so looking at between 0.5 and 1. Okay, so we halve that range, and a good way, if you can't, if your mind doesn't work, and obviously, I mean, it's quite obvious now that it's 0.75 that we're going to do next. But if your mind doesn't work like that, or we start to get ones where it's very hard to see specifically just off the top of your head where's halfway between 2 numbers, you add 2 numbers together and then divide by 2, and that should get you the halfway point. That's just kind of a little cheat way rather than trying to think through it. I mean, as I said, it's very easy at this stage, but you might get to numbers which are a bit more complicated. Well, this is further maths, even though I'm drawing a number line, I'm talking about halving numbers. Anyway, so as I said, the next value you would therefore try is 0.75, so f of 0.75. Okay, so you put f of 0.75 in your calculator, you get, you put 0.75 into that equation, so it's 0.75 cubed, take plus bracket 2, plus 0.75 times 2, or plus 1.5, take 2. It gets you an answer of negative 5 over 64. So basically it gets you a negative number. So therefore, again, we look at the intervals. Now between 0.5 and 0.75, we know that is negative because there's not been a change of sign between 0.5 and 0.75. So if we put 0.51, 0.52 and went all the way up in that philosophy to 0.75, they would all be negative numbers because the equation, we know it's an x cubed and it does something like this. It's not going to do this, okay? So we're not going to suddenly get a positive number halfway between them two. We know the y coordinate is always going to be negative between 0.5 and 0.75. And we knew it was already going to be negative on the left hand side of 0.5 anyway. So therefore we add them two ideas together and we know anything less than 0.75 is going to be negative. Okay, so we can, I'd leave that 0.5 on your number line and draw the new line at 0.75 and shade all the way on the left hand side of that. Now you don't have to do this idea and it probably makes you look a little bit thick, but it's just to keep reminding yourself, okay, what have we crossed off? I mean, you could just read your work, but I mean, who's got the time for that, right? So we know the change in signs between 1 and 0.75. And now this is how it comes into how accurate do you want it to be. Okay, so the next step we're going to do, we're going to look at halving the range between 1 and 0.75. This is where my idea of adding them together and halving it comes in. Okay, so 1.75, 1 plus 0.75, divide by 2, it gets you 0.875. So therefore the next value we're going to try is f of 0.875. Obviously you might be able to do that for your top of your head, and if you were, well done to you. Okay, just obviously you're smarter than me. Okay, 0.875, by the way, it doesn't take much. 0.875 plus 2 times 0.875, take 2. That gets you a positive figure of plus 0.42, okay, or 0.4199. Okay, so we know that there's been a change of sign between 0.75 and 0.875. Okay, so that's somewhere between these two values of x there has been a change of sign. Now we want it to one decimal place, okay? Now we don't know if it's past 0.85. If it's between 0.85 and 0.875, then we round it up to 0.9 as to one decimal place. But if it's less than 0.85 or up to, or from 0.75 up to and including 0.8499, then we know to round it to one decimal place the root is going to be 0.8. But we don't specifically know, what it is. So what we're going to continue to do is continue to do this method of halving it and halving it. So if we look at halfway between that range, a good thing to do is f of 0.8125, okay? And if you put that in your calculator, you get a positive figure of 0.016, 0.61, etc. So therefore, the change of sign is between 0.8125 and 0.75. So therefore, when we round it to one decimal place, the root x is equal to 0.8. Okay? Now that's pretty much the same method you would use for any equation or interval bisection method such as this. So what I'm going to do is I'm just going to read, because I've come up with some summary points here. Obviously, as I prepared earlier, it's almost like back to the days of Blue Peter. But what I'm doing is I've just created this little summary sheet which I'm going to read out to you. Obviously, I might show up to the screen and go read that, but I'm sure you want me to read it out. Okay, so that's pretty much the method. As I said, I'm going to go through another question such as this, following the same method. As I said, it's one method. It's quite simple. Okay, so really, so we get an equation like that, okay, like we said, where it's not really easy to factorise, and they will tell us a range that the root lies in. So in this case, it was between 0 and 1. Now, what I always do at the start of a question such as this is just prove to yourself that f of 0 is one sign and f of 1, or the other side of the range, has the change of sign. Just so you know you're following the right equation and you're using the right buttons. I mean, obviously you are, but it's just nice to emulate something like that. And then it's just a case of halving the range until you get to your desired range of accuracy. Now, if you want to break that down into certain points, the first thing I would do is, as I said, you don't have to do this, you completely know me, draw a number line with the ranges in it. So you can cross out where you know the range does not lie, where there is definitely not the change of sign. Okay, when you halve the range, you should get a positive or negative number, and between the two extremes, between the two extremes of the initial range you were given, when you halve that range, if that number is, say if you've got a positive extreme and a negative extreme, and you get half it and you get negative, then it's going to, where the change of sign occurs, it's not going to be between two negatives, it's going to be between the negative and the positive. So you keep halving that range, and you keep following the idea of halving the range which has a change of sign over it, okay? Which is kind of what we did with this number line idea, where we kept looking at the range where there was a change of sign and ignoring the range where there was no longer a change of sign, okay? Well, it was no longer, there never was. But they will tell you the range is between 0 and 1. Now, in this case, they could have told us the range was between 0.5 and 1, but that would have meant less work for us. So they've just expanded the range and made us focus in on it to a certain degree of accuracy of whatever is required. Okay, so that's a little bit of a summary thing. As I said, really, this entire method is based upon trial and error. There's no mathematical formula that you have to learn. It's more the method, which is halving the range and looking at the range which has a change of sign, and keep halving that until you get to your whatever degree of accuracy that you want. In this case, we were asked to find to 1 decimal place. Okay, so as I said, it's quite a nice method, really. It's nothing too extreme. Alright, so this next equation looks a bit more complicated, and it's probably something that you're more likely to see in the actual exam, but as I said, the method stays exactly the same, because weirdly enough it's the same topic, so they're not going to change the method. Okay, so we're given this equation of x, which is 2 to the power of x, which is the one we had before, 2 to the power of x, take x, take 3, equals 0, and we know there is a change of sign. We are told there's a change of sign between f of 2 and f of 3, or there's a change of sign between x equals 2 and x equals 3. Okay, so the first thing you would do, as we did before, is put in what f of 2 is and f of 3 is. Okay, so if you just want to do a calculator, so 2 to the power of 2 squared, take 2, take 3, you get an answer of -1. You get if you do that for 3, so it's 2 to the power of 3, or 2 cubed, take 3, take 3, and that's positive 2. So we know there's obviously, as we're told, change of sign. Now I'm going to do what I just did before, of drawing that sort of almost like a number line. I mean, you could come up with a more mathematical word for it to make yourself sound a little bit more intelligent, but you know, it's always nice to be able to dumb things down. Obviously for other people to understand, not obviously me, because you know, I'm too advanced for this stuff. Okay, so we know the range lies between 2 and 3, so they're the two extremes we're going to draw on. Now, as before, we're going to halve the range and look and see what the sign is. So we'll do f of 2.5 and see what we get. And if you were to do f of 2.5, you get positive 0.156. Okay, now let's compare which side of the range do we want to go on? Do we want to investigate between 2 and 2.5, or do we want to investigate between 2.5 and 3? Well, we need to look where the change of sign is. At 2, it's negative. At 2.5, it's positive. At 2.5, as we said, it's positive, and 3 is positive. So therefore, the change of sign occurs between 2 and 2.5. So we put a little dash on at 2.5, and we can sort of cross out the bit between 2.5 and 3, because we know the change of sign does not occur between 2.5 and 3, because this, I don't know what this curve would look like, but that's the method you just follow for any kind of curve, because there's no curve that is mathematical that does something like this, where you've got an X and Y axis like this, it will always be, I mean, we're not looking at a massive range here, remember, it's only 0.5 either side, so it's not going to have such a drastic change in that small range. Okay, now we know it lies between 2 and 2.5, but obviously we've got to give it to a certain degree of accuracy. Now, because this is straight out the class book, or my class book, it doesn't specify, it just says find the first and second approximation to x, which I assume is the first and second decimal place or whatever, I don't know. But we're basically, doesn't make me sound too good, talking about number lines and not knowing what basic maths is. I don't know what hope there is for me in the world anymore, but we'll just live with it. I'm just going to follow the method and you can decide when you want to stop. Although I'll probably do a few and you can continue it. Now, following the same method, we want to look at the range of 2 to 2.5. We're not interested in above 2.5 because after that, the sign does not change for what we're interested in anyway. Okay, so we have the range again and see what f of 2.25 looks like, because that's halfway between 2.5 and 2, which is the range that we're considering. And if you were to do the f of 2.25, you would get negative 0.493. Now that's obviously a change of sign, but it's a change of sign between 2.25 and 2.5. It's not a change of sign between 2.25 and 2. Okay, so we draw around where 2.25 would be and cross out everything to the left of that, because we know the range lies between 2.25 and 2.5. As I said, you can completely ignore this method and you can just think it through in your head, but either way you would be thinking of something like this in terms of what area, and it sort of eliminates any areas where you might suddenly decide to do 2.75 again. Alright, so we know it lies between 2.25 and 2.5. Now you could put 2.5 as positive and 2.25 as negative, but it's keep it nice and simple. So what we're going to do is half that range and see what it's like halfway between that. Okay, so as I said, you can follow my method of adding 2.5 and 2.25 and dividing by 2. And that would get you 2.375. So the f of 2.375, if you do, is negative 0.817. Okay, so negative 0.817, well 2.25 we said was negative, 2.5 we said was positive. So therefore the value lies between, the change of sign lies between 2.375 and 2.5. Okay, so anything on the left of 2.375 is negative, so can kind of rub off 2.5, and anything on the left of 2.375 is going to be negative. Okay, now you could continue doing that if you wanted to. We're going to follow the same kind of principle that we did before, where to follow to one decimal place. Okay, so it's obviously either going to be 2.5 or 2.4. So we halve the range again between 2.375 and 2.5, and that should enable us to do it to one decimal place. Okay, so 2.375 plus 2.5 divide by 2. That's 2.4375. Okay. Okay, and if you shove that in your calculator, it's negative 0.02. Alright. Now, therefore, we know the change of sign is between. So anything on the left, therefore, of 2.4375 is going to be negative. So therefore, the change of sign is between 2.4375 and 2.5. So you could do now 2.4. Sorry, let me just double check this. Yeah, so you could do 2.499 or whatever, so 2.4999, because that's half, because anything less than that, we know it's going to round to 2.4. See. totally. I'm getting myself. I've probably done too many steps actually. Yeah. Okay. So, as I said, it depends to what degree of accuracy that you want it. So obviously, it's not. It's going to be 2.5 to 1 decimal place. Okay. Because if we did 2.4999, so I'll do that now for you. So 2 to the power of 2.4999, take 2.4999, take 3, we get a positive answer. Oh, sorry. So if you did f of 2.4999, you get a positive answer. So therefore the change of sign occurs between 2.4 and 2.45. Oh my god, that is so bad. I'm sorry, I've made a complete hash of that. Yeah, probably because I've done it to too many decimal places. Yeah. Sorry. Yeah. Completely ignore what I was saying. That shows that it basically we've got a change of sign which occurs. Right, this is what I've messed up. I did 2.499 instead of 2.44999. So therefore, basically, you could work it out as your calculator. Really sorry, I made a complete mess of that. But hopefully you can see the answer is 2.5 because we've got a change of sign at 2.5. Okay? And if you just understood the first one is probably, first method, first question was probably better. Made a bit of a hash of that second one. Okay, so sorry about that. I will have another go at that one, but you know, we know the range is between 2.4375 and 2.5, so you could continue narrowing it down and decide to what area of accuracy that you want it, and you could discover the true change of sign. You could keep going on forever if you wanted to. I find it's a really, really high levels of accuracy, but you know, that's totally up to you. And I'm pretty sure I've just confused you, so I do apologise about that, but hopefully you're still alive and I've not killed you off just yet. So anyway, thanks for watching. Hopefully it's not been too boring, and as I said, I'm more than willing to do a couple of examples because I know that messed up, but just remember the first one, that's the key one really. Okay, so thanks for watching, see you next video.